So, hi everyone. So, in this video, we are going to continue with respect to model-driven telemetry options, and we're going to see how we can build on, where we left last time, where we configured the basic TCP-based option. So we are going to explore here in this video what are the transport options available, and we'll also take a packet capture to understand both the options, that is with respect to TCP and GRPC. So let's dive into the configuration aspect. So this is the XRD device that we have. So at present, we don't have anything configured. So let me show run telemetry model driven. So we don't have anything, right? So let's use the same configuration that we used last time. So I'm quickly um, configuring this. So what we are doing is we are using the same configuration, and in the protocol option we are using TCP. So we are going to send this traffic to 57,500, and our telegraph server should be receiving this data on 57,500. So we have configured this, and I'm committing this. So now from the XRD device, we are ready. So let me quickly go on to my telegraph server, and we look at the telegraph configuration file. So if you see the top portion of it, so we have an input section. So I'll just zoom this a bit for you. So this is the input section where we are saying to telegraph that you should listen on port 57,500, and the transport that you will be using is TCP. So we are good in that aspect. So what we'll do is we'll before we start, so let me also start my packet capture. So this is the packet capture edge shark window. So we are interested in the management interface. So I'm starting a packet capture which is going to listen on all communication from the management interface, right? So once this is done, let me start the server, the telegraph server. So I have started the telegraph server. Now it should start, the communication should start on port 57,500. So now let's go back to the XR configuration, and then let's check, whether the receiver is connecting. So we saw yesterday that the way we can verify this is show telemetry model driven summary, and we should see the receiver is in active state. Now we should be seeing some packet capture. So you can see that the packets are getting exchanged. So we'll stop this capture and analyze a bit. So we are interested in the communication that's happening between our device, which is 172.20.20.2. It is sending this data towards our receiver, which is the telegraph receiver. So I'll double click on this packet to further analyze this. So we have this data. The data is encapsulated on a TCP payload. So the source port is a random port, and the destination port is 57,500. So this is a normal TCP communication that's happening over IPv4. And but what you can see is you can see the data, right? So here, as I scroll through, so this is the data that's being exported by the router, and you can see what's the content also. So it's normal unencrypted communication over TCP. So we are fine with this. Now the next aspect that we are looking into today is the other option, wherein I can, instead of TCP, choose an option called GRPC. Now GRPC most often in production is used along with the TLS based security. But today what we'll be doing is not go for the TLS based security option. We'll look into this in further video, but let's change the configuration, and instead of TCP, we'll use GRPC. So I'm going to list the configuration that we already have. So this is the configuration that we already have. So instead of TCP, let's go for GRPC, and we should also change the port to another port, because our telegraph service, so let's quickly go over the telegraph service. It's listening on port 56,999 for GRPC communication. So that's something that we need to remember. So let's modify this existing configuration a bit in order to change the protocol from TCP to GRPC, right? So I'm going to the same section. The destination group is telegraph, and in the address family, so what I'm going to do is, first of all, let's do a no and remove this address family because we no longer want it, right? And then we'll do a quick commit. And now what we are going to do is we are going to reconfigure this. Instead of port 57,500, we are going to use 56,999, and the encoding is going to be self-describing GPB, and the transport that we are going to use, protocol that we are going to use is going to be GRPC. So this is one of the option that we are trying out today. So once we commit this, let's quickly check the running configuration that we have done right now. So if you see, we should have one configuration. It should say 56,999, and the protocol is GRPC. Okay, so we are good in this aspect right now. So what I'm going to do is I'm going to stop the telegraph service so that we can have a fresh packet capture, right? So what I'm going to do is I've stopped the the telegraph service. Now let's go to the Edge Shark and then initiate a new packet capture. So I'm going to close all the previous captures. So let us close the previous captures, and I'm going to start a fresh one, which is going to tell us exactly how the packets are getting exchanged over GRPC. So let the Wireshark load. So now it's a good time to start the telegraph service. So we have started the service. So we should see packets now starting to flow between the router and the telegraph server. So it has not yet started. So let's wait for a couple of seconds for the router to start sending data. We can verify whether our configuration is okay. So I see one problem here. The one problem that I see here is that we have chosen GRPC, and the specific option that we are interested in is GRPC with no TLS, because we don't want security. So what I'm going to do is protocol GRPC followed by no TLS and then commit, right? So I've committed this. Let me come back. So we have started receiving the packet. Now one interesting thing is, let's take this, stop this capture and observe this for a bit. We can see now the communication, the first SYN has started from the router towards the destination. So since we're doing dial out, now this is a very important point, because the router is initiating the connection, from an ephemeral port all the way till the 56,999 port where we are sending the SYN. But once the SYN exchange is complete, so how is the actual data getting exchanged? So it's getting exchanged on top of HTTP2. So now let's go over the actual data exchange. So now let's take one such communication between the router and the server. So you can see we are using HTTP2. HTTP2 in turn uses TCP, but if you see the underlay, so HTTP2, so now this is the stream of data. So there is this GRPC message, which is MDT dial out, and inside this we have the protocol buffers. Now, what we can see here is that we are sending the data using protobuf, and you can see this data unencrypted. We are still not encrypted it because we are using gRPC with no TLS. We are using self-describing GPP, which means that we can clearly see what is the field that we are sending along with the value. So that's something that's there in the clear text. So if you are security conscious, if you're deploying this in production environment, maybe you would want to try gRPC with TLS. But as of now, we have seen two options. One is TCP. We analyzed it in Wireshark and then later modified this to gRPC, and then once again saw that gRPC uses HTTP2, and inside HTTP2 we have protocol buffers wherein the data is sent. So that's it for this video. So we'll build on this day by day, where we explore all the options with respect to iOS XR streaming telemetry. Thanks once again for watching.